you want me to start testing?
Testing microphone, 1, 2, 3, 4, maybe a little lower. Lower, testing 1, that's good.
All right, ready when you are. All right, this is CS50, and this is week 10. And this, per our announcement via email and on the board here, is a little different from usual. Those of you who are students here on the campus will be focusing initially on a walkthrough of P-Set 8 to supplement the resources you have in the spec itself. We'll transition thereafter to Q&A on the past 12 or so weeks of the semester, covering topics especially from most recent weeks, if you have them. And then toward the end, we'll adjourn formally and then stick around for one-on-one Q&A if you have questions about the upcoming P-Set or quiz, or you're visiting from out of town or nearby and you would like to chat. But without further ado, perhaps a familiar face.
Hello, everyone. My name is Zamila. You may know me from the face hovering in your P-Set screens. I'm very happy to lead the walkthroughs for CS50, and in fact, I'm really happy to be back here in this format. Indeed, it's actually how I first started doing the walkthroughs, in-person sessions where I was able to really interact and see the people that are now just behind the screen. So I look forward to interacting with you and chatting and answering any questions you have.
All right, so we thought we'd begin with a quick conceptual overview of P-Set 8 and what is expected of it and where you're going to be going with it. Then I'll turn things over to Zamila, who knows the problem set best, to actually walk you through some of the distribution code and some of the goals at hand, and thereafter some of the quiz review. So spoilers first. If I go ahead and pull up the actual staff solution for this problem set at mashup.cs50.net, this is the app that you'll ultimately be making. And it's a mashup in the sense that it combines information from Google News, specifically a news feed, and it combines Google Maps, which of course is an API or application programming interface. And as you start to think about your final projects especially, it's via these kinds of techniques of combining third-party tools and third-party data that really makes it powerful and very exciting to actually build things in software these days, because unlike our days in C, where if you wanted to do something as sort of mind-numbing as like concatenating two strings, you had to do that yourself. But now, thanks to third-party APIs and the internet, and hopefully the mental model that you have from C to Python to now SQL and JavaScript, you can really think about programming as stitching together other people's ideas and software and contribution, building your own ideas on top of them so that what you can pull off is much more impressive and much more usable than it would be if you had to build everything from scratch. Recall our Uber example, right? That is, of course, a ride-sharing application and company, and they would have had a much harder time actually building that product if they didn't have something like Google Maps underneath the hood or some other piece of software with which to build their features on top of. So what does this thing actually do in terms of features? Well, by default here, we're at Stanford, California. If we go ahead and click on here, crossing our fingers, we'll see. OK, so we're going to choose some different news here in the world. We'll go to Los Altos, California. And that seems pretty benign. So here's the news in that part of California. And what just happened? So here is where your instincts should start to be a little more curious and a little more technical. How do I figure out what just happened in this application, even before I thought about implementing my own app? Well, your instincts moving forward, whether you're using Chrome or something else, should increasingly be to like poke around, like open up Chrome's developer tools. And when I do this, among the things I can certainly do is actually look at the HTML if I want to actually get a sense of how this thing is built. But a little more interesting today, ever since last week, is to focus on this network tab, which sniffs all of the network traffic between my browser and the server. But what's interesting here is that even though the map is already loaded, when I go ahead and click on, for instance, the news in Atherton, or let's say Menlo Park, California, you'll see that a whole bunch of HTTP requests were just initiated. And if I go ahead and focus on maybe this one, articles, you'll see that in the response there, though a bit small, we see what looks like what kind of data? What kind of format? Yeah, JSON data, JavaScript object notation, which is just to say a pretty lightweight, simple text format for representing data in a way that's conducive to sending it across the internet. And so it looks like, per the square bracket there and per the curly brace that comes next to it, that this is maybe an array per the square brackets in JavaScript. And each of the elements inside this array is what data type? What does the curly brace represent? Yeah, it's an object, which is the sort of maybe most versatile data structure in that it's just a collection of key value pairs. And we actually talked about this in the world of C when we talked about hash tables with which you can implement this notion of an object. Or you can think of it too in Python as a dictionary, or dict, which is a collection of keys and values. So what happened is I clicked on that marker. some line of code in JavaScript, the language we started looking at last week, said, hey, server, go to /articles, pass in a value of geo equals 94025, which apparently is the zip code for that town. And what came back from the server, our, and soon your application, is an array of news articles, each of which contains apparently a link, and if we keep scrolling, a title for the article. And then what did we apparently do in the staff's code and soon yours? Well, it looks like we took that pretty raw, ugly, machine-readable data, the JSON, and turned it into HTML, a prettier, unordered list with open bracket UL and open bracket LI and so forth that gave us that bulleted list of results. And meanwhile, and this is perhaps even neater to watch happen across the wire, let me clear my console there. Let me just get this town out of the way and clear it again. Let me go ahead and start searching for something like 0, 2, 1, 3, 8. And every time I did that, a new HTTP request was sent, and what presumably came back based on the behavior you just saw? Yeah?
It's like suggestions for places.
Yeah, suggestions for places. That's why this dropdown started with like a bunch of answers, and then slightly fewer, and then slightly fewer as I sort of refined my query by typing out more the characters or more numbers in the zip code. The last match and the only match in the end is 02138, which is great. And if I click that, I'm going to be zoomed away to Cambridge, Massachusetts. But why is that? Well, again, if you're curious and you poke around at, say, the first JSON request here and look at the response here, you'll see that what came back is a whole bunch of JSON. And this is a little more cryptic because it's got things like accuracy and admin code 1 and admin code 2, more of those in the specification. But that is just some of the data that you're going to be importing into a SQL-like database so that when you search that database, you get results just like that. And so lastly, if I actually go ahead and autocomplete on Cambridge, Mass, I'm whisked away to Massachusetts. We're here now are all of the nearby towns. And what you don't have to do ultimately is figure out what towns exist where. We did a bit of the geographic math to figure out, if you treat the world as flat temporarily within a small rectangle, what towns are within that rectangle. We hand you that kind of mathematical code, but ultimately we're going to hand you a really big file. So in fact, before we start to take a look at the distribution code, let me show you exactly that file. One of the things you're going to download for the problem set is going to be this big file here, us.zip. And in creating this pset some time ago, we kind of Googled around ourselves looking for a big database of US cities and states and zip codes because we wanted to have those types of information incorporated into the pset. Wonderfully, this data set here, which we've mirrored on our own CDN, but is from a publicly available source, allows us to download a zip file. And in that zip file is a folder with two files. One is a README, and literally some time ago we just read through this file to understand what is in this big zip file of data. And what's neat is that if we then open the actual text file, it looks like this. It looks a little messy at first glance, but you can perhaps glean that this is, of course, the US file. And you can actually download one of these for different countries, which is cool, which means if you're from abroad, you can localize this to your own town or country. Here are US postal codes here. Here are what look like the names of cities, the names of states, the abbreviations for states, things like counties and numbers that I'm not even sure what they represent offhand. Then we have some GPS coordinates over here and so forth. This is a really juicy data set. But it's not a CSV, because I don't really see any commas. So what format might this text file be in? What's that? Tabs, I heard. Yeah, and it's not obvious, honestly, from the file. But the fact that things kind of sort of look like they're in columns is kind of a clue that there's some consistent character. And maybe a user just hit the space bar in between all these fields. But more common is instead of using commas, sometimes people just use tabs. And tabs that are literally \t. And in fact, if I highlight this, you'll see that these are big chunks of text. It's just one thing. It's one tab character, not multiple spaces. And that's a key insight because when it comes to importing this data, the program you use is going to have to know in what format it is. And if it's not going to look for commas, it's got to look apparently for tabs. And so one of the first things you're going to do per the specification is load this database, which is pretty darn big, with thousands and thousands of cities and states. You'll load those all into a SQL-like database with a whole bunch of columns. And then subsequently, you're going to start querying that data. But to get things started, you'll have the distribution code that we provide. You're going to cd into that directory and recall run Flask. And so just to recap, before we dive into the code itself, what is Flask and what is it doing for us, both in pset 7 and now perhaps 8? Perfect time to cough. What is Flask? Yeah?
it like something that connects our Python code and the web formatting together so it can run?
Yeah, it's something that connects your Python code and the web so that it can run. And more simply, it is a web server. It's a few different things. But when you literally type Flask run, you are running a program called Flask, like any other at the command line. Run is a command line argument that exists because whoever wrote the Flask program decided to accept a command line argument called run. And what does that do? It literally runs a web server. And that we did talk about in past weeks, in our HTTP discussion, in one of our early Python discussions. A web server is just a piece of software that effectively listens for TCP/IP connections from browsers and other computers on the internet. And as soon as it receives a TCP connection on port 80, so to speak, if we really want to be precise, it looks at the GET request or the POST request or whatever it is, and then responds to that virtual envelope inside of which is a request with its own response. And so that is what Flask does. It is simply running a web server by default on port 8080, which is just a kind of a conventional but arbitrary port number to listen on, and it responds to HTTP requests. Meanwhile, Flask is also a framework, so to speak. And so when you import it in your application.py file, like you did per the distribution code in PSET 7, that's just a whole bunch of software functions, libraries that someone else wrote, the folks at Flask, that just make it easier for us to write software. And so when you have written your own application.py, and when you've added lines of code to this, and you have atop this file a line like this, from Flask, import Flask, and JSONify, and render template, and request, you're essentially just giving yourself features like this. The ability to say app route, and then define a route, and the ability to define a method underneath it, and so forth, because without Flask, we would have to write a lot of lower level code that frankly just gets tedious, not unlike C if we were trying to solve a problem there. So Python in and of itself doesn't necessarily make it super easy to make web-based applications, but if you use a third-party library like Flask, that gives you a lot of features for free. The ability to render templates, the ability to get the arguments from the URL that the user provided, and it just makes life easier and more pleasurable to actually build what you want to build without worrying about those low-level building blocks. So with that said, let me go ahead and turn things over to Zamila.
Great. So as David mentioned, we're going to be taking advantage of the API, of the different libraries, and indeed, as we become better computer scientists and better programmers, the amount of code that we're going to be writing from scratch is going to decrease. Why reinvent the wheel over and over again when we can utilize other such wheels and useful wheels that other people have created for us to make ultimately a pretty cool web development application? Now, ultimately in Mashup, what we're going to be doing is to parse RSS feeds from Google News using Python, and then we'll use those queries and display them on the map. So a user will be able to search and click on a marker and see the relevant news articles for that location. So let's start breaking this down, as we always do, into the different pieces that we have to do in order to accomplish this problem. So in terms of the distribution code that we've given you, there are several files to look over. We'll want to look into the Mashup database, into a Python file. Notable functions there is going to be articles and search. And then the JavaScript function then, moving from the Python backend to the JavaScript front end, we are going to look into configure, add marker, and remove marker. So that's just a little teaser into what we're going to be looking into today. Now, we already went through this a little bit already, but just to refresh your memory, you're going to want to be interacting with various things in this problem. We're going to be interacting with SQL, HTML, RSS, JavaScript, Python, jQuery, JSON, everything. So we're going to want to understand what belongs to what and which functions are going to belong in which sections. So let's look at the distribution code first. And indeed, we have nope. All right. Okay. So first we have index.html, and in here we have in the head some typical things, right? We have our CSS, we have some of the scripts that we're importing. So you'll want to look into this to see what scripts we're importing here. But what we see here, the most important part here, is this form. So in this form, in the staff solution, you'll see this text box here, where a user is able to input the query for the location that they're interested in. So that's the relevant part there in index.html. Now, if we continue, let's go to application.py. Now, we talked about how Flask allows us to render templates, so we're able to create a route to index. Now, we want to continue on and look into articles, search, update, and JSONify. So what are these doing here? So we have rendering index right here, which we talked about already. And so then now we have this route for articles, where the comment says that we're supposed to look up articles for geo. There you go. Now you can see what I'm talking about. All right, so now we see just a plain to-do here, where we return JSONify, and then it passes in an empty array. So clearly, we're going to have to pass in something here that allows us to look up these articles. All right, but let's keep on going on just to get a sense for what we're being handed. Then we have a definition for search, where we want to search for places that match our query. And again, we have this JSONify function. So clearly, we're going to want to look into this function to see what parameters we want to pass in and what format it returns to us. Now, update over here is actually written for us. There are no to-dos. So we'll want to look into this a bit more carefully to understand what's going on, but we won't need to write anything within here. So update will find us up to 10 places within view. And so that's what David was talking about before, where we already dealt with the map in terms of finding what nearby cities are there. So here we're dealing with some of the parameters, making sure they're in latitude and longitude format. We are exploding the map such that we're treating a round area of the Earth into a rectangle so that we can do this math. And essentially what we're going to be doing here in terms of finding the cities within view is we're going to execute a query to our SQL database, where we select from places, so that's going to be a column within the database, where the latitude and the longitude are within width, and we're going to limit that by 10 results to the latitude that we are giving in. Now, ultimately, it's going to output those places as JSON. And again, calling this JSONify function. But here we see an example of how JSONify takes in a parameter. Here, we're inputting rows as the input to the JSONify function. So now you see an example here by searching through the distribution code of how you might execute a SQL query to the database, get that result, and use that within a JSONify function. So again, something that you may be implementing yourself within the problem set, but here's an example of how the syntax and everything actually works. So once we execute and retrieve a series of rows from our database, if we store that in a variable, then we can then pass that variable, and then that's in the correct format to JSONify. All right. So now let's take a look at scripts, which is a JavaScript function. And so here we're going to be dealing with global variables. Here we have our map as a global variable, the markers as a global variable, and finally information. And so this is where we're really interacting with the Google Maps API. So if we look into here, then we have our global variables here. We have our map, our Google map. We have markers. Now, markers for the map is currently just defined as an array. We'll fill in those later. And then we have the whole window of our Google Maps as another global variable. We want to ensure that everything is properly loaded. We are loading all of our styles in. And then what I want to draw your attention to here is where we instantiate the map. So here we're using the Google Maps API to allow us to create a new Google Map, and we pass in the canvas and all of the options that we already listed above. So once we have this Google Map defined as a map, then we can execute functions on that map object. So once we configure it, then we're going to add some event listeners because we want to be able to see, we want to be able to listen for user clicks and keyboard interactions. So the first thing that we need to fill in is how to add a marker for a given place onto the map. So this is a to-do for us right here. So we're going to be wanting to deal with our map function and look into the Google Maps API for functions that will allow us to add and then later on remove markers. Don't worry, I'll give you some functions and give you some hints later on. But right now we're just going over the distribution code to figure out where we need to put things in and how everything fits. So here we have, again, adding a listener for whenever the map has been dragged around. We're going to want to update the map view and what we're seeing, as well as the zoom information. So again, these are all ways that we're manipulating the map. You can look into how the map can reset the center, things like that. Again, things that things that are in the Google Map API that we have used. So again, as I promised, there is a function to remove the marker. So we're going to, once we call the remove marker function on the map, we're going to want to remove the markers that we have added for those locations. Then I also promised you, remember, that we would talk about search. And so the search takes in some parameters, and then we see that it actually searches and gets the JSON from those parameters from the search, as well as showing the information for the marker with the given content of all of the news articles that are showing up. All right. So if we go back to our mashup database, then what we want to do is we want to import our us.txt, or if you're international, then any other file from the country of your choice into the map. And so we'll import that into the table places. Now, as David showed, we have just a tab-separated file in which we don't specify the types of those columns. That's something that you'll want to decide what the best way of representing that data is when you load it into your database. But relevant information there is the country code, postal code, the place name, as well as the latitude and longitude. As you saw from a quick glance at the distribution code, we'll want to be interacting with all of that information as we calculate, for instance, the 10 nearest places to display. So if we were to go to the staff solution, /articles, and I were to input, say, 02138, then what do I see here? Can someone describe what I'm seeing here when I input this URL? Yes. Yeah, so we have an array, as we saw, from the hint from when we were watching the network here as we were interacting with it live, but here I'm presenting it in a different format. So I'm showing you how we're actually retrieving the request for the given postal code here, right? We have a JSON array, and we have a link to a news result as well as the title for that result. So if I were to input 0213, then what do we expect to happen to the length of this file? increase, right, as the results for that increase, because we have more locations that match those parameters. So as you said, we submit geo to articles as a get parameter, and we get back an output of a JSON array of objects, where each object is going to be an article, a news article for geo. So remember that as the way we are going to retrieve that.
It's worth noting, sometimes a little confusing is when all of a sudden your articles end up being fake Onion articles, if you're familiar with the satire publication. That's to be expected, because sometimes Google News blacklists users if they're hitting their servers too many times in some number of minutes. So not to worry if you start to see Onion articles. That's baked into the distribution code if you look at helpers.py.
Now again, whenever we're dealing with user interaction, we always want to safeguard against any possible user error. So we want to check to make sure there's no missing argument and throw a runtime error if that is the case. All right, so now that we looked at how articles works, let's go to search, and let's do the same thing as before. So I'm going to go to search. And the parameter here I'm going to put in as 02138. Now again, we see in a different format. We see in a different format what we saw before in the network over here, right? Where we have a JSON, object right here. And so here we see all of this information for the state, the state abbreviation, name, county, country, latitude, longitude, and as well as the city name and postal code. So there is there's the result of the query there. But as we tested before, what if we were to not complete the postal code? Well, then we're simply returned a longer list of places that match that given query that start with that given postal code. So understanding how this works and knowing that when you pass into search, you're going to want to, as the user updates and types in, as we displayed before, types in the postal code, it's going to want to keep on fetching as every single digit of that postal code is added. You want to think of that then when you are querying your database and make sure that the data type represented in the postal code that we're searching in the database is going to lend itself well to functionality like this, where as we type in sequential characters, we will be able to match all of those results. So for instance, if I were just to begin with 0, then I would have indeed a very long array. All right, so just to summarize what we just went over, within search, Q is going to be submitted to search as a get parameter, and it's going to output a JSON array of objects, and each object from that row is now going to be from places. And so the value of Q, as we demonstrated just now, was as a postal code, but it could also be a city or a state. And so, so that's just to summarize how search is working. Then let's go into moving from the back end into the front end for JavaScript. We're going to want to go back now into how we configure our map. And so what we want to do is we want to go back and even Control F to find all of the to-dos that we need to do. We'll find one in configure that requires us to integrate the HTML and the JavaScript in order to display the matches for the query that the user is inputting. All right. So I promised you that I would give you a little bit of hints on the functions to look up within the API in order to do the functions such as adding and removing markers. So here we go. Within adding a marker, what we're going to want to do a couple of things. Whenever we add a marker, we want to instantiate that, which doesn't actually add it onto the map. We want to do that as well. We want to listen for clicks on the marker. So remember back when we instantiated in the distribution code the map and we added an event listener, something like that. Then for that marker, we want to get the articles for that place and build ourselves a list of links to those articles. remembering back to how we searched through the database. And then we want to remember that marker. Remember that markers up above was a global variable, and so perhaps we can add to that global variable as we add our markers in order to keep track of everything. So to instantiate the marker, I'm pointing you towards the marker library. So we're going to go to google.maps.marker, and then within there, if you look up the API, you'll be able to find functions that will allow you to instantiate add listeners, such as the following, where we have the add listener function. In order to get articles for the place, go back into the distribution code to see how we used the get JSON. That's another hint. So again, a lot of the actual functions and actual implementation are already given to you within the distribution code. It's just a matter of finding where that is. And then finally, remembering the marker, I already talked about this already. We have a global variable above called markers, and so we want to add to that array if we're representing it as an array, or perhaps you want to represent it as a different type of object. That's okay, as long as you're able to find a way of adding to a list and removing from that. So then finally, for removing the marker, we want to allow ourselves to remove all of the markers from the map and delete them. So again, going back into the Google Maps API to see functions that will allow us to do so. And so, oops. Now, if we take a last review of everything that we've looked at so far, we see how all of the different elements interact. We have our static template of our index that contains the form with which we're inputting the form in which we're inputting the queries. We have application.py, which is taking in those requests to index as well as articles and search, returning us JSON arrays of JSON objects. And then on the front line, once we have those objects, the JavaScript is allowing us to add and instantiate and listen for clicks to those markers that will then complete our first web app as follows. Let's see. That's not as happy. Oh, good. Always have to check the news. How's Charleston doing? Oh dear. Oh dear. Okay. Let's go to Seattle. Oh no.
Disneyland.
Okay, Disneyland.
Oh.
Oh no, that's okay. Well, how about Palo Alto?
No, I went there.
Oh no, oh, you went there. Okay, how about Providence? No, oh dear. Oh, can we find a city?
Suffice it to say, you could go somewhere and get news.
Suffice it to say, how about that could be something that your users could then find, is find a city where hopefully there is some glowing news to feel good about.
So last night I spent some time at office hours and thought we'd conclude this portion of the walkthrough with some advice based on what we saw. So I think one of the most common mistakes to make, honestly, is not tackling the problem set in the order in which we've suggested you take it. Honestly, the specifications are written in such a way that when we have the sort of getting started section and the downloading and most importantly the understanding section of the spec, if I can tab over for just a moment, realize that these are sort of these implicit hints along the way to draw your attention to things that will hopefully prove very salient when it comes time to implement one or more of those to-dos. And another habit we've seen at office hours and the like is something that's not consistent, for instance, with some of Zamaila's own advice here with this slide. So this list of checkboxes via which you can tackle add marker really should be taken literally and not all at once, but truly one at a time. And indeed, the opportunity when working on your version of Mashup is that when you first go ahead and run the application, as I could do, for instance, here, if I go into my Mashup directory and do flask run, that'll spit out the URL that I can visit. And if I open that, if I open that up, I'll get an internal server error, which is actually appropriate because this too was like the #1 error we were seeing last night. What does this mean? And where do you begin to actually diagnose a problem like this? Well, this is scary, and you don't really want to see this. But how did I get here? Well, let me go back to my terminal window. And sure enough, if I give myself a little more room, that's a lot of errors for code that I didn't even write, so to speak, if I've just downloaded the distribution. But among the things you'll see is that highlighted in yellow are lines in the output of Flask that will hopefully draw your attention to what it is that is wrong. Now, traceback just refers to a stack trace. It's just Python's way of describing the same thing that we talked about in C, all of the functions that have been called thus far. I'm going to skip over all of the white text there and focus only on this yellow text down below, which is actually more on point because it's referring specifically to application.py, line 28, and specifically the error I've encountered is API key not set. Zamaila referred to this earlier. In the spec, you'll learn more about this. But long story short, when using third-party APIs, it's very common to sign up for them, whether for free or for pay, and to then be given an API key, a big random-looking string that you send with all of your requests so that the company can log that you're using it, how often you're using it, and therefore how to bill you if it's actually a commercial service. So what I forgot to do was actually set my API key. And I won't go through all of the steps here per the spec to do this, but it's essentially going to have me type this command, export an API key that equals something like 1, 2, 3, 4, 5. But it's going to be a longer string than 1, 2, 3, 4, 5. And it's going to have some characters in it. And as soon as I do this, this has set something called an environment variable, which we glanced at a long time ago when we talked about memory and how it's laid out in C programs. One of those chunks of memory was called flagged for environment variables. But essentially, that command there, which seems to have had no effect, has set a special variable in the memory of my terminal window so that hereafter, anytime I mention the keyword API key, it's going to be equal to 1, 2, 3, 4, 5. And the motivation for this, even though it seems a little complex, is just so that this way, all of you can sign up for your own API keys. All of you can configure your own IDEs with your own API key rather than with a classmate's or the staff's, so that your application then in index.html from the distribution code ends up having, very subtly, this line here. There is a script tag in index.html, which we give you, that ends with a get query, an HTTP parameter called key. And this syntax here is actually Jinja syntax. And this is essentially saying plug in the user's key right there. And so therefore, we have configured index.html to tell Google to use your API key as opposed to someone else's. But long story short, suppose now we've solved that issue, and I actually have my map up and working. It's not going to look as functional as this one here. You're still going to have a text box. You're still going to have a map. But you're not going to have any of those markers. And you're certainly not going to have news. And so per Zamaila's suggestions, what does this actually mean in concrete terms would be wise? Well, the very first thing you could do is just figure out how to plant those red markers on the screen. How do you begin to even think about that? Well, the spec and Zamaila's video walkthroughs will provide you with some more detail there. But literally, if I Google Maps API JavaScript, let me go ahead and click on, say, the first result there. And then if I glance at the various options that appear on the screen here, I'm going to go ahead up to Guides. which is something we point you to too. And if I just kind of skim the side here, and this is exactly how we figured out how to make this problem set early on, I went to markers, and sure enough, what I will see in this kind of example code is a relatively small snippet of code, albeit out of context, that's going to show me how to use Google Maps API to put a marker on the screen. And so version 0.1 of your app, so to speak, should probably end up having just red markers, no text, like no city names, no ability to search, no ability to click, but at least you've gotten one of those checkboxes done. And then per Zamaila's suggestion too, what the second checkbox would be is exactly as she said, figure out from the documentation how to add a listener so that anytime you click on one of those red icons, something happens. And maybe it's something stupid. Maybe you use alert, open paren, hello world, so that you click on a marker and it just says something. Then at least you can see the cause and effect. Then that, of course, is not what we want you to do. We want you to open an info window, one of these little white boxes above a marker. But for that, you know what? If I dig a little deeper in the documentation, look at this, info windows. I will see documentation on Google and a sample string that's sort of excessively long for demonstration's sake, but how to open up a little white window above the marker. And I really can't emphasize this enough, not only for this piece set, but honestly, as you're exiting the class and sort of on your own in the real world doing these things, take these baby steps. It's not at all meant to be diminutive. It's meant to give you these very concrete opportunities for successful outcomes so that when something invariably goes wrong, in our code as well, you know that it's got to be isolated to only the 10 or 20 lines you just wrote, not the 100 lines you tried to do over the course of 2 hours of office hours all at once. So by all means, keep that advice from us both in mind.
I would definitely stress that. With the API, with the distro code that we're handing you, it's a gigantic toolbox with which we're asking you to build this big web application. But before you go and do that all at once, make sure that you understand how each one of those tools works. Like David said, make a small marker that just places itself on the map so you know how to do that and you know how to do that. Then build on from there.
Indeed. So any questions on PSET 8 and mashup, or the requisite JavaScript ingredients? Yeah.
Do we have to keep exporting our API keys, or can we just load it into the HTML so we don't have to wait for it anymore?
Good question. Do you have to keep exporting your API key? Technically speaking, you should paste it into any terminal window in which you're going to run Flask. And so another common mistake at office hours has been you've got 2 terminal windows open, which is great because it means you can kind of multitask, but you exported the key over here, but that means it's only in the memory of this terminal window, and then you ran Flask over here, which means it's not found. So you could just paste the API key into both of those terminal windows, which is probably the right, if overly simplified, approach. You could technically paste it into index.html, but that's not best practice because then you're going to submit your API key to us, and now we can run up your bill, so to speak, for the API if it actually costs something. So generally, putting API keys and usernames and passwords in your source code, not good, because they end up on GitHub, they end up publicly accessible, and so forth. The best approach, actually, even though we don't teach this in CS50 per se, is that in a Linux environment, which is what the CS50 IDE is, you can actually edit special files. And I'm going to go ahead and do this, open .bashrc. So it turns out secretly tucked away in your IDE accounts have been a bunch of dot files, files that literally start with a dot, which by default makes them invisible. So when you type ls, you don't see so-called dot files. One of these on a standard Linux system is called bashrc, for bash resource, I think. And that is simply a convention for a file where you can put configuration that is loaded every time you open a terminal window. So if you really wanted to save yourself some keystrokes at the bottom, you could literally do export API key equals 1, 2, 3, 4, 5, or whatever it is. Save this, close it, and thereafter, every terminal window you open in the IDE will have that environment variable set. The staff will not see it because it's not going to end up on GitHub because it's not in your source code. It's only in your environment. So that would be the best way to do this, I would say. Good question. Other PSET 8 or JavaScript questions? All right. Well, let's context switch to give a quick overview of how we got here. Then we'll adjourn the more formal part of this morning. Stick around for questions about the quiz or anything else. But just to give you a sense of what lies ahead, whether you're actually taking the quiz next week or at some point will be or want an opportunity to reinforce, here's kind of what we have done this semester. There's been a few more lectures than these where we've gone deeper into some of these topics. But we started, recall, the semester in Scratch. And we've ended most recently now with JavaScript. So it's been kind of a long road. And it's felt that way even more so perhaps via the p-sets. But what should you be thinking about as you prepare for something like a quiz, or even to sort of graduate from a class like CS50 to figure out what the concrete takeaways are? Like, we don't particularly care if you are experts in C or in Python or in JavaScript, because the reality is even I don't always remember some of the syntactic features of these languages or how to do certain things. And that's why Google and Stack Overflow and these tools do in fact exist out there, so that you can kind of remind yourself of the minutia that is useful, but it isn't necessarily like intellectually enabling. What we hope you get out of this arc of the class really are some of the fundamentals that are going to persist years after some of these languages and certainly some of these APIs and frameworks fall out of vogue. Flask is not likely here to stay. Something else will come along that's better and greater and will replace it. And so that's not where you should be spending your mental energy as you forge ahead, both for quiz and beyond. So what were some of the takeaways, for instance, from Scratch? What do you think is probably useful to have gleaned from those days of the class? Yeah?
Abstractions.
Good, abstractions. So actually thinking about certain puzzle pieces as abstractions for more interesting behavior. For instance, if you had a turn left instruction in Scratch, well, what does that actually mean? That might actually mean to sort of rotate a piece or to move it some number of pixels, or however it's implemented. I don't care. I just care that the Scratch sprite actually turns in some direction. Or more concretely, when we implemented custom puzzle pieces, those purple puzzle pieces where they were custom functions in Scratch, that is the best example of an abstraction, because you can make Scratch, I think we did cough, like with a little cartoon bubble on the screen. But that's really just implemented with a say block and maybe a loop and some kind of parameters. And so abstraction, indeed, is one of the best takeaways from that time in the class. What else? Yeah. Good. The logic of building blocks and connecting lines of code together. So functions, not only, but also loops and conditions and variables and some of the fancier features like events and threads as we discuss them. But keeping those kinds of takeaways in mind, because we've seen most of those same constructs in other languages. And one of the purposes of some of our slides showing you left and right, like C and Python, is to say it is really not that intellectually useful to remember, or to focus on, rather, like where the semicolons go and where the parentheses go. Obviously, you've got to get accustomed to those over time, but that's not like the hard part. The hard part is understanding like what role these puzzle pieces play in actually solving problems. So moving on from there, we talked about C. And C, of course, is pretty low level. And odds are 99% of us in this room, myself included, really aren't going to have many occasions in life to use C. That is not the goal of introducing it. In fact, I use C about once a year, and it's usually around September to October, because there are just more useful tools for the kinds of problems that I tend to solve these days. C is absolutely still used. It's absolutely very high performing. And indeed, if you think back to the delta between our implementation of Speller in C and Python, so darn quick and easy to implement in Python. But if you actually run the code, the C version would still be much, much faster. And so anytime people really care about performance, or if you're implementing software on devices like our phones that relative to our laptops are more resource constrained, using a language like C is pretty darn compelling. But one of the takeaways from C really is something like this: memory. So with what power do you get from using C? Yeah. Pointers, which for many students, myself included back in the day, were kind of one of the scariest things or the hardest things to wrap my mind around. And this is the reason that we so repeatedly focus on like what a stick of memory looks like. And if you think of it as this grid of bytes that you can write data to, there's really nothing all that interesting going on underneath the hood. It's just up to you to move things in memory or to go to locations in memory. And that's all that pointers allow you to do. It's like the proverbial X marks the spot on a map that takes you to some destination in your memory. And with memory comes the ability to build things and to solve problems. So algorithms and data structures are so intertwined. In fact, there's many courses where it's not just about algorithms or just about data structures. They really have both names in the title. So what is a data structure? What is it? No, you're just yeah. A container for data. Yeah, a container for data. And what other characteristics might a data structure have? Right, because we've got like arrays, and we've got hash tables, and we've got linked lists. There's lots of different ways we can contain our data. So who cares to choose among one or the other? Yeah?
Efficiency in retrieving the data.
Yeah, that's a good one. Efficiency. And efficiency of what? What's your unit of measure?
So you can do it
Good. Time. So efficiency of time is a big one. And what's the counterbalance often to time? Space. And so this really is thematic even as far back as our earliest days in CS50, where yeah, you can absolutely do better in terms of solving some problem. You can solve it much faster, but you're going to have to pay some price. And those prices might be you're going to have to spend more space. That is how merge sort, for instance, performs so much better than bubble sort, selection sort, insertion sort, because you use literally twice as much space. If you think back to how we implemented that, we kept moving numbers around on the screen, and that was meant to suggest that you're indeed using twice as much memory. And so you spend more memory and you save time. Frankly, merge sort was a little more difficult to wrap my mind around. And so like there's another price, which I don't have 3 hands, but like developer time and sort of cognitive overhead is a very reasonable resource to keep in mind. Like I'm much more comfortable implementing bubble sort because it's so darn easy. And who cares if it's super slow if I'm not using it that often? And so that too is among the trade-offs to consider. Algorithms, beyond those. Like, what is an algorithm, just to be clear? Those are examples of them, but say again? Steps, yeah, steps for solving problems. And so it's this really fancy way, and it kind of is spelled in a way that makes it seem fancier than it is. It really is just like step-by-step instructions for solving some problem. And one of the takeaways, too, we hope, from the class and as you think about preparing for the quiz is how you go about solving problems. One of the harder questions on the test for many students a few weeks back was actually sort of figuring out what the running time was of an algorithm that we prescribed when it came to like shuffling cards and so forth. But at the end of the day, if you just look at the pseudocode or the actual code for a program and just ask yourself, like, how many times is this line of code or pseudocode going to run? And think about the indentation, because the indentation is typically there just for us humans, but it often suggests that something is going to happen again and again if it's a loop, or maybe optionally if it's a condition. And so think to yourself, as maybe back for the test, like how many times is this block of code going to execute? And from there, can you kind of infer how good or bad an algorithm is? And then we turned our attention a few weeks back to these yellow topics, which are all of those that post-date the test. And so even though the test is cumulative by design, you can't really forget what a loop is or what abstraction is, we'll focus the remaining questions on these yellow topics here. And so we began to bridge old and new with HTTP, which is what? Yeah. Hypertext Transfer Protocol, which is a really fancy way of saying it is a way that two computers communicate. So we had this human example that I did with someone else in the audience last time. Oh, hello.
Hello.
Nice to meet you.
Nice to meet you.
And now we're sort of done with this social convention or protocol. And Zamila just knew when I extended my hand, odds are she should probably extend hers as well. And we had a little pleasantry there verbally, and then done with the transaction, so to speak. And HTTP is kind of the same way. A browser sends a request in the so-called virtual envelope saying get or post or something else. And then the web server, or Zamila, responds in a manner consistent with the request that I have actually made. So that's the interesting part of HTTP. With it, we talked about IP and TCP. What was one of the takeaways from IP, an internet protocol? Like what ideas should come to mind when you think of IP? Yeah?
It's your address.
Good. Internet protocol tends to refer to addresses. So we have unique addresses, like I might live at 33 Oxford Street, Zamila might live at 1 Oxford Street, and those would be the unique addresses via which we can get mail, or in the case of the internet, packets of information. What about TCP? About TCP. Transmission control protocol. Good. But what does that mean in real terms? What does it give us? Yeah, guarantees not just receipt, but delivery. And it's always like guarantees, because surely something could still go wrong, like the internet just doesn't work or whatnot. But it guarantees delivery in that TCP ensures that there's acknowledgement of the data. So if I send like that picture of Happy Cat some weeks ago, and only 3 out of the 4 packets make it to Dan all the way in the back, TCP has a convention using numbers that will let me know, oh, Dan only got up to number 3. I had better resend 1/4 of that cat so that he can complete receipt of the whole thing. And TCP helps with that. And it also does something as or even more important. In what other context have we talked about TCP? Yeah.
Is it error codes?
Error codes. That's HTTP status codes, I think you maybe mean. Like 400, 404, 500, those are HTTP. So you can think of like IP as being here, TCP as being here, HTTP as being here, because HTTP just assumes that there is an internet and there is TCP/IP. So those error codes are application layer. What about TCP? There are numbers involved in TCP, but they're not error codes? Yeah. Yeah, the port numbers, right? Because servers are, again, often just computers, and computers can surely do multiple things. And if I want to be able to visit a website on a server, it needs to know that I'm requesting a website and not my inbox for my email or not sending a chat message or the like. So servers, like web servers, mail servers, chat servers, video conferencing servers, and the like, tend to have unique unique numbers associated with them, 80 for the web or 443 for the encrypted web, 7 and 465 for email as well. So these numbers that identify certain services. And that means a computer can do more than one thing. So in fact, on CS50 IDE, when you guys run Flask, you're very often seeing port 8080. And even though we are not going to be running like thousands of websites on the same IDE, that just means that that is the unique number via which you can access your website to distinguish it among the other things that the IDE can do. Dynamic programming. So we did this one at Yale. And this was focusing more on algorithms independent of any language. And what was the essence of dynamic programming? What was the biggest takeaway? Distillation of? Yeah, breaking it down into smaller pieces for sure, but toward a very for a very compelling reason, though. What was that? This was what she was chopping up into different sizes and trying to figure out which way to chop it. Like, what was one of the key takeaways from dynamic programming? Yeah. Exactly. Storing the results of past computations so that when you have those same exact questions again for some future calculation, you don't reinvent the wheel, you don't redo the same math, you literally just look at your answer from before. So the simpler way of describing this in sort of maybe slightly more familiar terms would be caching, C-A-C-H-E, whereby you're caching, remembering the result. The fancier way of describing this is memoization, which sounds curiously like memorization, and it kind of is the same thing. But memoization, which is exactly what Benedict was doing, means you keep an array around. Maybe it's one-dimensional, two-dimensional, maybe it's even a dictionary, but you remember your past computations so that if you're building up a really complicated problem, you never ask the same question, or rather, you never answer the same question more than once because you just check your previous answer. And it was meant to significantly improve the running time of an algorithm. All right, 3 topics to go then, all of them languages. So Python, out of curiosity, who has preferred Python over C? So it feels like most. I could kind of go either way. It kind of depends on the problem. And Python, I'm still learning, frankly, a lot of its features because there's just so much more baked into it. And the documentation alone is much more overwhelming than what's even available in C. And why? Those of you who raised your hand, is Python more compelling so far? Even though you've spent arguably much less time with it. Yeah? Good, higher level, and you pretty much defined in your answer like what higher level really means. It's a lot easier and quicker to do things. You have a lot of abstractions to your comment earlier that just make it easier to do certain things. A lot more functions built in, a lot more fancy syntax. Things like lists just kind of grow and shrink for you. You don't have to worry about that. So you can kind of understand programming now and just take for granted the fact that if you want a hash table, write one line of code and we'll give you a hash table. You don't have to reinvent those wheels yourself. But what's a price you pay? There's nothing for free. So why might you not want to use Python? Why might you want to stay with C for some problems? OK, yeah. Good. So you end up using more memory, perhaps for Python, because there is some overhead to it. In many cases, Python is effectively interpreted, which means it's not converted directly to zeros and ones and then run by the CPU inside of your computer. There's literally a program called Python that's reading your code top to bottom, left to right, and kind of doing what your lines of code say. And let me tweak one thing. Don't think of it as being converted to C. Think of it as being compiled to some other language. Python is often compiled to what's called bytecode, which is not C, but it's a language that something called the Python virtual machine understands. So one of the key takeaways, too, when we first introduced Python is when you just type Python something.py, there's actually a whole lot of stuff happening that you don't have to worry about or do manually like we did with C. And it's all toward an end of optimizing the code. And we've disabled this in the IDE, but by default on many computers, Macs and PCs, when you run a Python program called application.py, very often will another file be automatically generated. Application.pyc for compiled, which essentially contains the bytecodes to which I alluded, which isn't quite zeros and ones. It's a little higher level than that, but that is used the next time you run application.py for efficiency. So the Python interpreter doesn't need to do things again. But again, to your point, higher level, who cares about all of this? You might if you're really engineering a highly performing solution to a problem, but that's not the case when we're making mashups and websites and so forth, where we can afford to spend a little more time. Other takeaways from Python versus C? Then how about SQL? Structured query language. It's not quite the same as these other languages in that we haven't looked at it in the context of like loops and conditions and functions, though those features are essentially there. They just tend to be more sophisticated features that you don't often need. We focused more on the verbs like select and delete and create and update and insert. But what does SQL do for us? It's not a database itself.
It's the query language.
Good. It's the query language for a database. So a relational database in particular, and a relational database just means what? It has tables, and a table is just rows and columns, and that might relate to other rows and columns. That's all the word relational database is referring to. SQL is the language that allows you to query that data, select the data, change the data, and this is in contrast to something super simple like a CSV file, comma, separated values, or a TSV file, tab separated values, like us.txt, which we saw earlier. And so with SQL, we have the ability to not just query data and update data, but also to do it efficiently, because what do databases like SQLite or Postgres or MySQL or Oracle or others support? What were some of the features we talked about of a database? How can you make a database answer your queries faster? Yeah. Indexing. So if you, the developer, exercise some foresight and decide, OK, I know I'm going to be searching on email addresses quite often, I might index that field. Or I know that my email addresses should be unique, so I'm going to put a constraint and say this column must have unique values to protect myself from myself so that users can't register multiple times. And for something like mashup, too, if you know you're going to be searching on like zip code a whole lot or city name a whole lot, you know what? You should probably put an index on that column so that the table is not being searched exhaustively, linearly, top to bottom, every darn time Zamila or I type 02138. You want it to be faster. Now, how do those indexes work? Again, to your point of abstraction, who cares when you're using it? It is intellectually interesting, and that is the study of computer science, but it's what you're getting for free by using, for instance, one of these tools. But free is relative. It's also harder in that now you have to know another language, SQL, to access it. There's more code to write than there was with CSVs. But again, trade-offs. And then lastly, JavaScript. We spent relatively little time last week, and you'll spend time with it if you haven't already with PSET 8. But how is JavaScript different from SQL and Python and C? Yeah? Say again? Client side. OK, so that's in contrast, presumably, with server side. And what do you mean by those two distinctions? Good. JavaScript, as we've been using it, runs on the user's computer, our Mac or PCs in the browser, as opposed to on the server, which historically has been where Python has run in our PSETs, as well as where C, of course, has run within the IDE. And that's important because it means you can provide features for your web-based applications that keep running in the user's browser, even after index.html or whatever has been downloaded. And in fact, to our discussion of Ajax earlier, with all of the demonstrations Zamila was doing with getting 0 and 2 and 1 and 3 and 8, each of those was inducing another HTTP request from browser to server using a technique called AJAX, but really running code client-side to talk to a server which has its own code written in Python that responded with some JSON data. And so even though it really might feel a little overwhelming that we have Python and JavaScript and HTML and CSS and JSON and all of this other stuff, each of them solves a specific purpose. And we're just using them to talk to one another and to, again, kind of stitch together these different features to make something more interesting. So as you prep for the quiz or you work on PSET 8 or your final project, like keep that in mind. Like, why am I using JavaScript? Why am I using Python? And don't worry too much about all of the intricacies of the languages themselves if you really understand the role. Because using documentation and resources like the walkthroughs and Google Maps API, can you kind of figure out how to do the specific things within each of those worlds. Any questions? All right, well, let's conclude with just some advice, which I can't emphasize enough because we put it in the About Quiz specification, how to prepare. So this is an ordered list based on my own sort of instincts of how best to optimize your limited time when it comes to preparing for this or any kind of exam. Reviewing the notes. Chang, one of our teaching fellows, does an extraordinary job like rewatching every lecture and scribing a sort of canonical set of notes to supplement or even replace what you yourselves might do. The source code from lectures tend to be useful insofar as they really are designed to be stepping stones. A lot of our demos start with version 0 and then 1 and then 2. And usually version 0 is like pretty bad. It's simple, but it's not very well done. And by the time you get to version 2 or 3, that's the well-designed solution to some problem. But understanding the trajectory, why am I doing X to Y to Z, to really improve the code is a helpful takeaway. The slides, which tend to not have much content, but they at least kind of punctuate the lecture or the semester and give you a sense of what the higher level concepts were. The review session, which will be coming up from the course's heads this coming Monday. It'll be streamed live online as well. Take a look at the website for the days and times, for the times and location. The lecture video, I wouldn't necessarily recommend rewatching or watching for the first time all of the course's lectures from the past several weeks, because that's not the most efficient approach at this point, but that's certainly an option as well. And number 6 is one of the biggies. It is not a good strategy to just look at last year's quiz and be like, OK, I got this, while you're checking the answers. Like, do it for real. Like, lock yourself up in your room or your home for a little bit. Do each of last year's 6 or so questions, giving yourself like a half an hour for each. And do not look at the solution until you have something of your own written or typed out to compare it to, because it's all too common for students, and we see this all the time when we chat with students after the test or the quiz about what they could have done better. It's so much easier to look at the solution and realize, yeah, that makes sense. But if you don't have that sort of aha moment on your own and kind of struggle for those 29 minutes to get to that point, it's not going to have the same sort of conditioning for muscle memory and the like as you would otherwise get. And then lastly, the problem sets too, just so that you understand some of the takeaways there. So again, do consider approaching your studies in this tiered order. Any questions then about the past semester and the upcoming quiz? Yeah?
How much of dynamic programming are we going to cover in the quiz?
Good question. The quiz will be roughly 6 problems total. So out of the number of lectures that we have, if I had to guess, maybe 1/6, but that's a very generic answer just based on how many lectures there have been. It's not going to be half. It's not going to be 100%, but it might be some non-zero amount. That's probably not helpful. Other questions? Other questions? All right. Well, thank you so much for joining us. We'll stick around for one-on-one Q&A. Please feel free to join us thereafter, and see you next week, perhaps.